What if I told you that we can cool things down? Well, that's kinda silly. I mean, of course we can cool things down. Let's put it another way. Can we cool things down like forever? Well, the answer is no. There is a limit to coldness, and it is called the absolute zero, which is equal to 0 degrees Kelvin. We may call this temperature a platonic law. Physicists fantasize with it, but it is unreachable. But we can get really close to it, like super close. The coldest temperature ever achieved is 0.000000003 degrees Kelvin. As I said, super close to zero. Now keep this in mind because we'll come back to it in just a few moments. Let's now talk about another thing: solids, liquids, gases, the three well-known states of matter. The only thing they have in common is what they're made of: atoms. Atoms are like the building blocks of our universe, and pretty much everything is made up of them. Now, if all three solids, liquids, and gases are made up of the same thing, how can they be so different to one another? The answer relies in the space between the atoms they're made of. To make it simple, in solids, atoms are tightly together and they don't vibrate much. In liquids, atoms are together but not so tightly and they vibrate a little more. And in gases, atoms are spread and they vibrate a lot. Done. There's a fourth state of matter called plasma, which is pretty much a gas with electrically charged atoms, but that's not what I'm here to talk about. I'm here to talk about the fifth state of matter. That's right. Here's the deal. You have a substance, say rubidium, and since you're bored to lockdown, you just cool it down. Like, for fun. Once you've done that, its atoms will have come closer to each other. Keep cooling it, and guess what? Its atoms will have become even closer. But, as we said before, we cannot keep cooling it down forever. We can only cool it down as long as we stay over the absolute zero, because that's an unreachable platonic law. Now, hear me out. Something really weird happens when you get close to this platonic love temperature. Like, besides from being friend-zoned. However, to understand this weird thing that happens, we must know the following. Atoms do not always behave like little footballs or Legos. They can also behave like waves. It may help to picture them as a weird, unclear, fuzzy little thing, like a cloud, maybe. And the lower the temperature or energy these atoms have, the more significant this wave behavior becomes, and the larger the waves themselves become. Now, here's the thing. We know that waves can interfere with one another, just like when you form two ripples in water. So, getting back to the point, when you cool something close to the absolute zero, you make its atoms come so close to each other that as these atoms behave like waves, they'll start interfering with one another. And as a consequence, all these atoms/waves become one single thing, just like when two or more waves interfere with one another and become one single wave. So, all the original atoms lose each of their identities and start behaving as if they were all one single thing, because now they are one single thing, a superatom. Now wait, this must have a name, right? Right. These super cold and weird behaving substances are called bosons and condensates, and they are considered to be the fifth state of matter. And with them you can make amazing stuff like superconductors, which conduct electricity without any resistance and energy loss, and have practical applications all the way from telecommunications to medicine. Or superfluids, liquids with zero viscosity, which means they can flow forever. Bosons and condensates are the future. And remember, if you ever see someone who looks really cool, remind them that they'll never be as cool as bosons and condensates.